Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Red Alert Lab. This is the video number 80. Before discussing what we have been saying in the previous video, I have a small announcement to make. All of my previous videos and all of my coming videos I dedicated to my father's soul. May Allah bless his soul and to be with him in heaven with all of our beloved ones. So let's discuss what we have been saying in the previous video. In the previous video we have been saying that we try to implement a group policy to force the Windows user interface language to be in Russian, because all of the Russian army understand the Russian language. Okay, they do not understand English, so we need to transform the Windows from the English language, or the Windows user interface from the English language to the Russian language. Actually, because I didn't have a Windows DVD or ISO image in Russian, so I have installed the Windows in English language. Then I have modified it or changed it to be displayed in Russian language. This has been done using a group policy and to install the Russian language pack to the Windows operating system. So we have done this in the previous video, and we have also changed the warning message or the welcome message that appear for every user in the domain before logging into the machine. We have changed it from displayed in English language to be displayed in Russian language to the Russian users, and also this warning message to be displayed in Japanese for the users in the Japanese army and on the Japanese workstations. So every army will see the warning message or the welcome message in his own country language or in his mother language. Okay, so in this video we'll discuss a very important concept, something called DNSSEC. So we all know that the DNS, it is a concept. We have said before that most of us doesn't remember numbers, and we all know that for any computer to talk to any other computer in a network, every computer should have a unique number which is called IP address. Okay, so most of us don't remember numbers. So the DNS ease this process by giving the machine not only an IP address but give it a name. So what we will do if you need to talk to another machine, you only need to talk to the DNS, give him the name of the machine, then he will give you the IP address of the machine so you can talk to it directly. So this is the function of the DNS. Okay, so we need to secure this process. Okay, so this process have two parts, the DNS server and the client. So the client, if he needs to talk to another client in the network and he doesn't know the IP address of this machine and he knows the name, so he needs to talk to the DNS server. So DNS server is one part of the equation, and the other one is the client. So the client send a request to DNS asking him to give him the IP address of a certain machine with him in the same network, and he give him the name, and the DNS server gives him the IP address. So we need to secure the connection between the client and the DNS server, so no one can hack this process. So what even this happened? So someone can say, what if a hacker can hack this connection between the client and DNS server? Simply, he can go and hack this process, and then he can redirect you to another machine or another server or another infected machine. So by this you are for example, forwarded to a machine that contains a virus or contains a malware or something. So the connection between the client and the DNS server should be secure. So here comes the DNS Sec concept. Here we are securing the connection between the client and the DNS server in a domain or outside a domain. For example, if you are for example trying to access a website, for example Google, www.google.com, you should send the name to an external DNS server, and then the external DNS server will reply to you with the IP address of the Google website, okay, which is for example any number you like, okay. So this also should be secure. So to secure both processes inside your domain or for your internal DNS servers and the external DNS servers, here comes the option of DNSSEC, and we will in this video set up this option in our internal DNS servers. But let's see a small video discussing the concept of DNSSEC. So here it's making the internet infrastructure more secure. This is not only for the DNS external servers, but for your internal DNS servers. The domain name system, it is a building block of the internet. It is a part of the core infrastructure. DNS maps easily remembered domain names to IP addresses, or it is mapping the name of the machines or the name of the web servers, okay, mapping it from a name to IP address so you can talk to it. IP addresses that identify specific computers. So this is one, and let's continue with the video because it will show us how this process is done. So for example, if you are trying to access a website, okay, outside your network, so for example www.examplebank.com, so this is the name, so you don't know the web server, okay, or the name of the IP address of the web server that is hosting this website. So you will ask a DNS server to give you the IP address of the web server hosting this website. So let's see the process. Example.bank.com. So the request is sent from the computer to an external DNS server. This could be Google's DNS server. So the DNS server will reply with an IP address, okay, and send it back to you. Then you can communicate with the website. So this is for a bank, for example. Then you can reply back to the bank and then begin accessing your website or accessing your bank account or something. Anyway, so this is a very simple process. DNS replies with the IP address, then send you the IP address, and then you communicate with the bank directly. This is what we see now in this video, okay. And then you put your username and password, and then you can access your account easily, okay. So this is very simple, okay. But this connection, okay, to the external DNS server, it's not secure. So let's see what will happen if the connection is not secure. So you are trying to access a website, your machine will send the name to an external DNS server. Here a hacker will intercept, okay, the connection to a cloned or an infected DNS server. It will give you a wrong IP address, not the IP address of the web server hosting the bank website, to another machine that he, for example, have on it malware or something. So now the connection is hacked. He is redirecting you to an external or another malicious server. This server is not the server that is hosting the website of the bank. So if you try to access it, here it is, we can see here that it is looking the same. So to make it more difficult to recognize, he is giving you the same bank page, so you not so you are easily deceived. But this is not the IP of the web server hosting the bank website. So when you try to put your password and username, here we see that he will give you an error, for example, that this is not a valid password. Actually, this means that he will know your password. So if you go there again, this means that he has already recognized your password, okay, and he will save it and use it later, okay. So this is a process of hacking the DNS server request. How we can secure this kind of connection, how we can secure it, we will secure it using something called, so now what happened here, the hacker, after knowing your password, what he will do, let me get back again. So what he will do now, he will get back again, again. So now, after going to his malicious server and trying and see a fake bank page, he got your password, then he can go to the bank and communicate and get your account. Okay, or at least not doing this, then he can redirect you to the right web server without knowing that there is a hacking process. So to be more not to be easily discovered, you see here invalid username and password. Actually, this is not the original page of the bank, but this is a fake page, and after getting the password he will redirect you to the correct bank website, then you can access your bank. So this makes the process of discovering the hack more difficult. Okay, this as what I recognized. Okay, so here this process should be secure. How we can secure it? By encrypting the connection between the client and the DNS server by using certificates. Everyone will have a certificate, so the connection between the client and the DNS server is secure. Okay, this is how we can do this, by securing the connection by issuing certificates from the DNS server side and from the client side. Here we can see that DNS security extension attach a special kind of information called cryptographic signatures. So he will encrypt the connection to the server, and this is done using a key, encryption key. Just a moment, guys. So let's continue, guys. Here we need to secure the connection between the DNS server and the DNS client. So we'll use the DNSSEC approach. This can be used with external DNS server and clients, and between also, or can be used in internal DNS server and clients in your domain. So we'll implement this concept, okay, in our domain or with our internal DNS servers. We will see how we can do this, but here let's see what will happen after we implement this process, how the connection will be secure. So here, for example, the same example, here we are trying to access a bank website, and we are requesting from the DNS server to give us the IP of the server. Here, what will happen? Our request is sent encrypted. Okay, so if any other server except the DNS server we are talking to, so for example, I am sending my DNS request to Google server. If any other server tries to send me a wrong IP address, it will not go, because I am encrypting my request, encrypting it and sending it to the Google server by a special encryption key. Encryption key, part of it is with the client and part of it is with the server. So if any other server try to intercept and take my request, he will not be able to do this because he doesn't have the encryption key. So this is why this process is very, very useful. So let's see here, if you try an external server to send the request, here we see, for example, I am using my key to encrypt the data or decrypt the data. Here it will not do because the server sending me the request doesn't have its signature. Let's see, or let's make it more simple. I am encrypting the connection and I am signing the connection. So I am sending a request to Google server with my signature on it, and the Google server should send me the IP address or the reply on my DNS request by signing also this request with the Google signature and Google encryption key. If anyone try to send the reply to my DNS request other than Google, I will try to see if the request is signed by Google signature and his encryption key. If this doesn't go well, or if the encryption key and the signature is not correct, the request will be blocked. Okay, I will not continue working with this cloned server or this malware server. Okay, so this is a very good thing to do. Okay, so here we can see that here you say address cannot be validated because this is not request, or this request is not sent by the right server or by the intended server I need. It's not Google server, it is a malware server. So here we can see this is a very simple thing or very simple video describing DNS let's see, DNS Sec. So let's see another video. Okay, actually this is one animated one with some things here. So here we can see that. Let's go from the start and let's get it also by some video or some sound. So let's go there.
Credit card information, like your John wants to buy a book online. He submits his credit card information like he always does. Everything seems normal, but what John doesn't know is that what he sees on his screen is just a set piece set up by a scammer. How can this happen? Every computer on the internet has its own IP address. To save web users from having to remember long series of numbers, the domain name system connects unique domain names to the IP addresses. When John types a web address, his computer sends a request for the corresponding IP address, which enables his computer to contact the server hosting the website. The call is passed down a hierarchy of so-called name servers until it reaches a server that recognizes the address John wants to access. Normally, machines trust the first incoming answer. This means that a scammer can bombard the machines with false answers. The result is that John will reach a website that looks real, but is in fact controlled by the scammer. If John then enters his credit card information, it may be abused. There is a solution to this. Its name is DNSSEC. DNSSEC will ensure that John receives a valid answer from the name servers, and that the answer has not been changed along the way. When a domain name is secured with DNSSEC, all replies to requests for its IP addresses get a signature. If a computer receives a reply about the domain without a correct signature, it rejects the reply. This way, John avoids accessing a false website. DNSSEC secures one piece of the big puzzle that is the internet, and ensures that John and all the rest of us safely reach the website we want to visit.
So we can see this is another video describing very simple way and in animated way what is the DNSSEC. Let's see another video also describing this one. So this is another video.
This is Tom. This is the captain. Tom loves the internet. He likes to keep himself up to date with the latest design news. Wow, a submarine for cats. Why not? That's exactly what I need. Tom says to himself and proceeds to make the purchase. It's usually a simple and quick process. Just enter your credit card and contact information and press. What now? What's going on here? Is this really the work of malicious internet crooks? Oh no! Tom is going to lose every last cent. Well, maybe this wouldn't have happened if the site Tom was using to order his product had been using DNSSEC. DNS what, you ask? Let us explain. When Tom entered the address of the website and pressed enter, his computer started to make queries to different name servers to get the page location as a response. If the queries are not secure and internet crooks have unleashed their clever and evil plans, you might end up in a hijacked environment instead of the intended website. It might not look different from the real thing, but it has been set up with the sole purpose of stealing the most important personal details of the buyer. By misusing them, the criminal is able to deplete the buyer's bank account, and in the worst case scenario, steal his identity. You, the administrator of a website, can lend a hand here. To ensure the security of your online visitors, you can protect your website with the DNSSEC security keys. That way, you can be sure that you will not have to deal with dozens of disappointed Toms, and hundreds and thousands of new and old customers will keep visiting your website again and again. Read more about the benefits of DNSSEC at www.internet.ee.
So you can see this is very simple videos describing what is the purpose or the sole purpose of DNSSEC. This can be done externally on external DNS servers and also internally on internal DNS servers within a domain. So let's see how we can do this option, or how we can set up this option within our domain. So let's go and see how we can do this. Let's see this one. So let me show you all how we can do this. So here we have two domain controllers, and in the same time they are DNS servers, so we need to implement DNSSEC on both servers, and we need to tell our clients to use secure connection, or make our clients be able to encrypt the data they are sending to the DNS server, and they can able to encrypt and decrypt. So we need our group policy to force our clients, when they are requesting IP addresses of or other clients of other servers within the domain, they should send it in an encrypted way, and they should have an encryption key, and the encryption algorithm should be available on their machine. So let's see how we can do this. So here, first of all, we need to go and open the DNS server. Let's first see what is this. Is the first DNS server, or the primary DNS server. If we go to this is the DNS, or the forward DNS zone. If we right click on it, we can see this is DNSSEC signed zone. So here we are signing the zone by our signature, okay, and with an encryption key. So this, he's saying that the DNS server RESO is the key master. He is the key master. He is the primary DNS server. He is the key master. What is the key master? The key master is a DNS server that generates and imagines crypto keys for DNS protected zone. So he is the only server that will, or the primary server, or he will be the only server issuing cryptographic keys, okay, and sending them to the clients. He is the primary, or he is the key master, okay. I think there is another one, he will be a secondary key master, or other. So I think this the primary, or this the primary domain controller, or the primary DNS will be the primary key master, okay. He will be the one signing the connections to the clients, and I think the additional domain controller, or additional DNS server will be the secondary key master or so. Anyway, so we will continue doing this. Then we will continue. Here he is telling us, or what we'll do here, just wait for a moment again. So here we need to here this key is authentication. The case is an authentication key that corresponds to a private key used to sign one or more signing. Typically the private key corresponds. Anyway, so I don't know what is this, but we need to here choose the kind of encryption algorithm that will be used to encrypt the connection between the DNS server and the DNS client. This should be an encryption algorithm that is available on the server and available on the client side. Okay, so let's see. We will choose a secure one. We tell him add. Here we are using RSA SHA 256. Okay, I think this is available on the client side, as long actually on the client side and on the server side. So here we can see that replicate this private key to all DNS servers authoritative for this zone. So this encryption key will be replicated to the secondary DNS server, okay, which is on the additional domain controller. So we'll have the same key, so we can encrypt the data, okay, with the same encryption key. So this is thing we will continue with the same, or we will go further, and we will continue using this encryption, and then tell him okay, and then tell him next, and then we'll tell him next. We wait for a moment. I think again, no, okay, I think we'll need to go further again. Just a moment. Again. I think here, this is the one. This is the new KSH, I think. Next. Okay. And then next. And then this is zone signing authentication. Is authentication key that correspond to a private key used to sign zone data are rolled over more frequently than KSSH. So there is two kind of keys, okay. Anyway, so we'll continue working with it. We will add another encryption key. So this is two keys, not only one key. We will add it, everything with the default. So we will accept the default setting. So all of this we don't need to know the details, but here this we can how we can encrypt our DNS server connection. Here enable the distribution of trust anchors for this zone. If there is also domain controller, trust anchors for this zone will be distributed to other DNS servers running on a domain controller. So this is it. Yes, we have another domain controller. If the DNS server is not a domain controller, a trust anchor for this zone will be added only to the local trust. Anyway, so here is he's trusting the other DNS server. Anyway, so as I said before, we will not go in the details. This is how we can make a DNS sec connection or secure our connection. Just enable the option, and after enabling it, it will be replicated to the additional DNS server, and then we need to, after that, issue a group policy to force the clients to use our secure connection to the server, and to encrypt also the connection to the server through the client. So let's see how we'll do this. Next, so we will accept the default setting. Next, 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 and then he's signing the zone. So finish. After that, we will see something like a lock on the forward zone. So this means that our connection or our DNS server is secure. Okay, so this is one we need also to see if the other domain controller or other DNS server on our additional domain controller is also secure. Here we can see this is the key, or this is a lock. This means that our DNS server is secure, and we can see there is signature. There is something called DNS Sec. So here our DNS connection is secure. We need to inform the clients that our DNS server is secure, and they should also encrypt the connection to the server using our encryption key, or using another key, or another private key or public key whatsoever. So we'll do this using a group policy. First of all, we need to go and add or see if the additional DNS server also is secure. So this is our first domain controller and primary DNS server. We need to see if the additional DNS server also the DNS on it, or DNS server on it, is secure. So here I am trying to add my additional adding another DNS, and then we need to connect to a DNS server. This is the additional DNS server, RACC02, and let's see if this is replicated, or this configuration is replicated to the additional DNS server, and if our additional DNS server is also secure. Okay, this is another thing. So let's see if this is secure. First of all, it will take a little bit of time. So here we can see that no, it's not secure. If you wait for a couple of minutes, refresh it for some time, we will see that it is also have a lock on it. So that means it is secure, but we need to wait for some moment. This is the first part. We need to configure DNSSEC from the server side. We need to configure DNSSEC on the client side. This will be done using a group policy. Through the group policy, we will inform the clients that they are using a DNS secure zone, and they need to communicate with the server using encryption keys. Okay, so here we'll try to resolve a name. First of all, I'm trying to resolve. This is a command through the PowerShell. Through it, we need to resolve, for example, a name of a server or a name of a machine, and we will see if, for example, the reply will tell us if the DNS server resolving the name is secure or not. So this is the full name of our server, which is racc01.redalert.internal, and then we need to resolve the name to an IP. This is the name of the machine and the server, or the DNS server that will resolve the name. They are both the same in our situation. Okay, so here we'll try to see, and here we are putting the DNS sec. Okay, so let's see after doing this if he will reply saying to us this is secure or not. So here we are issuing a command to know if the connection to our DNS server is secure or not through the PowerShell. Here we can see that this is also secure, so both our DNS server are secure. So let's see if we are trying to resolving the name of the machine, if the resolve result will be secure. Okay, so let's go and tell him okay. So let's see the result. Here we can see that okay, this is the name of the machine. This is let's see if he have tell us the IP address. Where is the IP address? Okay, here he's saying to us that this is the name and this is the query, and here we can see it is signed. So this is signed. I think here this is a resolve DNS server. This is he is telling us if the resolving query is encrypted. Here we can see it is signed, okay, and the signer is readalert.internal. This is the DNS server, so we can see it is signed already, signature. This is the encryption key, I think this, and there is TLL, and from there we can know that this query, it is encrypted from this kind of data. So, and here we can see, yes, here we can see the result. Here this is the query, this is the IP address of the machine, and from here we can see that it is signed and it is encrypted. So this means we are successfully encrypted our DNS server connection. So let's go and see. This is for our server. This is our primary domain controller. The connection to it is secure, but we need to have a workstation trying to connect to the DNS server. We need to force the client to use a secure connection to our server and to encrypt the data he's sending to us through an encryption key to secure the connection to the server. Anyway, so here we will see that get DNS, what is this command? Get DNS client cache. Let's see here. Here from this command, he is telling us if the client is using, or DNS client, if the client is using a secure connection to our server. So this command should be issued on the workstation. Okay, so here we can see that no, this workstation, the POW, is not using an encryption algorithm, or it's not using a secure connection to our server. We need to force the POW workstation to encrypt its connection to the server. Okay, so we need to do this using a group policy. Let's see how we can do this. We need to force all of the workstations in our domain to use an encryption connection, or to encrypt their connection to the server. So this will be done using a group policy. So let's see how we can do this. Go to a group policy, and then we will create a new group policy. Okay, DNS Sec policy. This should be applied to all of the workstations in the domain. We have already applied DNS Sec on both servers, so we don't need to do anything more. Here we need to force DNS Sec connection to the workstation. So we'll do this. We will do a configuration from the server side and from the client side. Here, what we need to do, here we need to tell him name resolution, and then put the suffix. Here we need to put the DNS server name, or the DNS domain, which is readalert.internal, and then tell him enable DNS Sec in this role. So here this will force the users or the workstations to use DNS Sec, okay, when connecting to the server. But let me go quickly here. So let's go further. I think here. Okay, so what we will do here we will tell him, just wait for a moment. Here we have done this. We tell him add, or we have already. Let's go further back again. So here we tell him readalert.internal. This is the name of the domain, or the DNS domain name, and then enable sec so and so, and then apply. And then we should by this group policy, after applying it to the workstations, they will use a secure connection to the DNS server. So here we can see this is the domain. Let's try to resolve a name through the POW workstation. So let's see how we can do this. So if you go further let's go and apply, okay, and then close, and then go to the PowerShell and try to resolve a name or resolve an IP address. So here we can see I have already forced the group policy. So I tell him what, let's go back here. What I have done here, tell him after that, let's go further. Here I have tell him to gp update / force to reinforce the DNSSEC group policy, okay. And then let's see if we try to resolve a name, if this name is resolved in a secure way. So let's go here and try to see if the resolve issue or the resolving of the name will be in a secure way. So let's go there here and tell him resolve the name, okay. So this is resolving a name. Here we can see that the resolve is done in a secure way, okay. So we resolve, this is the DNS server, but let's try to see if the client here we can see this is resolving the name also in encryption way or in a secure way, but we need to get the DNS group policy. Here we can see that it is, let's go there. Here namespace is not .sec.secure. Here we can see from this one that DNS validation or DNS Sec validation required true. So that means that this client is using a DNS secure connection to the server, okay. So this means that the connection to the server is secured from the client side and from the server side. So this is another thing we need to take into consideration. We tell him gupdate / force again and press enter. This is not, let's go further and continue. So after forcing this one, let's go further here. Then if we have done this, here we can see this is the domain name, it's not the domain name, and then we have the DNS Sec validation required true. So that means it is requiring DNS Sec to be used, okay. So this means our connection to the DNS server is secure. So this is a very good way to secure our connection to our internal DNS servers. If we try to resolve the name, we can see that both DNS servers are using the DNS Sec through the signer or signed or signature. So that means that all of the DNS servers are using a secure connection. I think we can go further here. Let's go further. I think this is not something to say. So hope this video is informative for you all. This is how we can install or set up DNS Sec in our domain. Hope this video is informative for you all, and thank you all for viewing. Thank you so much.